So my name is Austin Bingham. I work for and part own a small company in software consulting and development company up in Norway called 60 North. And as you can see, I'll be talking about high quality decision making using something we call open design proposals. These are nothing revolutionary. You've probably seen things like them before. We just kind of put a name on it and tried to classify what we mean, what are the good things about these different design approaches we've seen used in open source and closed source projects, and turn them into something actionable for teams that are doing design, doing architectural evolution, or something along those lines. Right, so let's just dig in. So, as you can probably tell from my accent, I'm not from here, and I'm also not from Norway originally. I'm originally from Austin, Texas. This little orange dot over here, that's the home of the University of Texas, Hook'em Horns. And it's a great city. If you've never been, you should definitely visit. It's great food if you like kind of spicy food. They're big in Tex-Mex there. I like this picture because it shows the city in the background. It's a beautiful city, not a big city, but it's nice. And it's a statue here of a guy named Stevie Ray Vaughan, who's a local music hero, great guitar player. And Austin's really big on its music scene. And I like the fact that we have a statue of him in the town. About 6 years ago, I moved to Stavanger, Norway, here on the west coast of Norway. It looks a lot different. This is a fjord here, the most beautiful fjord in the country and probably the world, and nobody can argue against that. This is right in my backyard, literally about 20, 30 minutes away. Really, that's what the whole country looks like. But the statues in Norway are a bit different. This is down really close to my house, actually. The three swords, they call it. These 20, 30 meter high swords jammed into the earth, representing the unification of the kingdoms of Norway back in, 1300 or something along those lines. So both great places, both beautiful places to visit. Don't come in the winter, maybe come in the summer if you're coming to Norway. Otherwise it's just kind of cold and dark. Unless you like that kind of thing, you can go skiing. But enough about me. Oh yeah, and 60 North, it was founded up in Norway about 2 years ago. So, we're talking about open design proposals, and we'll get to what that is, but I want to kind of motivate the discussion a little bit with a discussion of architectural evolution, which is where I sort of have applied these techniques the most, and sort of the most rigorously. So what is architectural evolution? So we can start with a little story. This is the Citicorp Tower in Manhattan. So it's not really the Citicorp Tower. This is a Lego representation of the Citicorp Tower, but it's the best picture I could find of the building, so I chose that. But architectural evolution are changes to architecturally relevant aspects of a system you can read, and particularly to the form, the shape of the architecture, not the technology so much. And this building is really interesting from an architectural point of view, an architectural evolution point of view. If you look down at the bottom, I think most of you can see it, there's this little gray building here, and that's a Lutheran church that's been in Manhattan for 100, 200 years, a long time, long before this building was conceived of. And it's in the middle of, some of the most expensive land in the world. So Citicorp decides they want to build this building, and the church says, well, you can build your building on this block, but you have to build over us. You have to somehow build your tower to sit on top of us, and we're not moving, we're going to stay here. And Citicorp said, well, okay, we can probably sort this out. And they hired an architect named Le Mesurier. I'm sure I'm slaughtering the name, but a French architect, and probably the most famous architect of his time. Certainly very influential and smart guy. And he scratched his head and thought about it and said, okay, yeah, here's what we can do. What we can do is put supports for the building here, not at the corners where you would typically put the supports for a skyscraper, but put them on the faces. And because of that, inside this building, there are these chevron bracing structures that kind of focus the weight onto these. I'm focusing the weight. I'm not a civil engineer. I don't know if that's a thing or not, but that's how they made the weight of the building sit upon these pillars. This new sort of revolutionary design. And this design is great. They did all the math, and they said, yeah, the building is going to be just fine if we built it this way. It turned out that this design made the building exceptionally light, so it would move a lot in the wind. And they calculated all this ahead of time. They knew how to do this. So at the top of the building, there's this 55-ton concrete block. It's controlled by a computer on rollers, and when the wind blows and the building starts to go this way, the block comes over this way, and the building's center of gravity stays more or less the same, so the building doesn't fall over. So this block is important for the building's stability, so it doesn't crash down into Manhattan. So they build this building, Right, this building is up, people are working in it, it's in the middle of one of the most crowded cities in the world. And this graduate student in Canada, architectural graduate student, gets an assignment to analyze this building. And she does some calculations and kind of scratches her head and does some more calculations and eventually concludes that if a strong enough wind hits this building on the corner, it will fall over, right? Now these are called quartering winds, I believe they're called. And they're typically not calculated for buildings, or they're not followed up very closely because they are almost never relevant to typical skyscrapers. A skyscraper with its corners, with corner supports, isn't affected that much by quartering winds, and so they didn't pay much attention when they built this building. But it turned out that, in fact, this building was very susceptible to quartering winds. And she figured this out and sent him, not an email, because this was back in the 70s, but some kind of letter to Mercier and said, hey, I think your building might fall down. And he said, yeah, well, he kind of looked at it and did some numbers, and he concluded, in fact, it would. It was very susceptible to these high winds. Now, these weren't typical winds. These would be winds that would come in something like a hurricane. So he did some calculations and said, okay, if a hurricane comes along, it's going to have a certain velocity of wind, knock the building over. What's the likelihood that a hurricane of that strength is going to come along sometime soon? And once every 55 years, roughly, is how often you would see a hurricane of that strength, which do show up in New York. So he kind of wiped his brow and said, good, we've got time to fix the building. We've probably got 20 some odd years to fix it statistically. But then it occurred to him, wait a second, what else happens when hurricanes come? Hurricanes show up and they knock the power out. And when the power goes out, the concrete block at the top of the building stops moving. And then he said, well, this is really bad because now hurricanes that can knock this building over come once every 16 years. And then he looked at the weather and said, and there's a hurricane out in the ocean right now coming our way. So he's freaking out. They've got this building, people are in it, and it's going to get knocked over by a strong enough wind that shows up. And they calculate the way to fix it is to go in and to put in some special rivets all throughout the building. And they did this in complete secrecy. Like the people are doing whatever it is they do at the Citicorp Tower. And there's teams inside the wall putting in rivets, and nobody's telling anybody. I think the emergency teams knew that this building might fall over, but that's about it. In the end, the day was saved. Right, the building still stands today, and it's still sitting on top of a church in the middle of Manhattan. The reason I like to tell this story is because this building represents an evolution in the architecture of skyscrapers. Skyscrapers, at this point, we knew how to build them. We'd been building them all over the world, and they stood up. We understood. You put the weight on the corners, and they stand up, and hurricanes can't knock them over. Not a problem. But because of this new factor that nobody ever had to deal with before, it forced a change in the architecture of the building. And even something that we've been doing for thousands of years, building buildings, we screwed it up in this case, and we screwed it up in an almost catastrophic way. As software developers, and some of you might call yourself software architects too, if we are trying to compare ourselves to people who build things like this, we are light years away from the sophistication they have in terms of math and science that they apply to what they do, and they still mess it up. They still build buildings that can fall over in the middle of a crowded city. So this is the main point of all this is that it's a fun story to tell, but it's getting things right, getting architectural evolution right is really, really hard. And it's a question of keeping track of all of the data that's coming into the system, all the stakeholders, and all the factors that you have to juggle. And those factors can number in the hundreds, and they all confound, and they make the job almost impossible, even for people building things that we've been doing for a long, long time. So what's a kind of evolutionary, architectural evolution in software? What are we seeing these days? A really big one, and there's some talks at this conference on this topic, is going from big monolithic single process applications, 1980s, 1990s style programs, to multiple communicating processes, microservices, and CSP, and that kind of stuff. And this is happening. And the kinds of things you have to think about when you are making this change are questions of deployment. It used to be really simple. You put a binary in place, run it, things worked. Now you've got a couple of binaries, maybe application containers, and they have to talk to one another. You have to learn the cap theory, all this kind of stuff that just makes things really difficult. Not only that, but you might have to then go to your sales and marketing team and go, hey guys, can we actually sell this separate from that? And they might say, yeah, we really should think about that. So now you've got all these other issues you have to concern yourself with, not just technical issues, but business issues that you have to think about when you make a change like this. And this is happening. Is there anybody in this room who is doing something like this, who's migrating an architecture from, yeah, okay, so 2 out of maybe 20, that's a pretty high percentage. Okay, it is a software conference, but still. Another kind of very popular sort of architectural evolution we're seeing a lot these days is this move from persistent final state, saving your file down to disk, to something like event sourcing, where what you've kept track of is the history of the changes, and you can reconstruct your file at any point. And this is a really, really powerful technique that gets applied to arenas that involve auditing, or that have to be able to travel back in time and see the prior state. And so a lot of people are looking into this kind of stuff. And this has a lot of the same flavors, a lot of the same problems that the microservices change had, which is that you have to now start thinking about all these different confounding factors that didn't bother you before. It's not just a technical change. It's now changed about things like deployment, things about marketing, things about security, things about auditing, and all these other factors that you have to keep track of. And we all know this is really hard. So the inherent complexities of these kinds of large changes, these kinds of architectural changes, are pretty straightforward. They can just be overwhelming. There's going to be too many things for you to keep track of. But very often we find that a company or an organization takes two smart people, they're architects, puts them in a room and says, figure it out. Go sit down, write, draw all the UML you need to do, whatever it is, and come to us with a solution that's going to address all these problems. And that is a recipe for disaster. I mean, many of you have probably seen this happen. Two people, even really, really smart people or a team, can't keep everything in their heads at once. We're just not built to do that kind of work. And even if you do come up with a great design, a design that meets all the needs of your entire organization and will last for 10 years, communicating that change to the people who have to implement it can be really tough. Making sure they understand your intent, making sure they understand how to do what you want to do and how it can be done, and that they ultimately follow the design so that your perfect design becomes a perfect implementation. Not that anything's really ever perfect in our business, but. And it's also really difficult, finally, to keep in mind what I call domain wisdom. You might look at a program and say, well, this bit over here is done really poorly. I would have done it in a very different way. But there's a guy down the hall who knows why it's written that way, and he could tell you why your approach is actually flawed. And without getting a lot of eyeballs and a lot of thought and everybody's input into the design process, you can't really access this. Unless it's in the heads of the two people doing the changes, you can't access it. So really, what's a poor architect to do? You're trying to make a change, and you have all these people who have really valuable input into the changes you're trying to make, but they're asking questions about, what about all this GPL code? What are we going to do about licensing? How will we test that? That's a big thing these days, TDD and BDD, and just testing in general. What do we do about our existing customer data, right? If you switch from some system over to event sourcing, you have to really think about how you're going to affect your current customers. Maybe you only know C# as a development team, but you're proposing things that are best done in Haskell or something like that, I don't know. All of these inputs, all these signals need to be dealt with and need to be processed in the decision-making process. And this is a really hard thing to do. What we need more of is tools. We need better tools, better methodologies, if you want, to help us make the right decisions when we're faced with these overwhelmingly complex tasks. And that is where what we call open design principles come in. They are a way to help make sure that you communicate what you're doing and that you get the input from the necessary stakeholders, the important stakeholders, to make sure that the decisions you're making are technically feasible, they work for the business, and that they don't miss any important marks. So, let's, and I should preface the rest of this by saying that, okay, I just talked about architectural evolution, but really any change, any big decision, even small decision you're making in software can benefit from approaches like this, from keeping the decision process, the decision development process open. So what are the key qualities of open design principles? In some sense, open design principles are sort of science. They're an observational science. We looked around and said, we see successful projects doing things that are kind of the same. We see common elements coming out of the development of this piece of software and this programming language and this protocol. What are they doing that allows them to be successful? And we found common elements and tried to identify them. One is that the decision-making processes are typically light enough or heavy enough for whatever environment they're in. If you read about agile stuff, there's this notion of method tailoring, right? Somebody says, you should be doing such and such to achieve this goal, but you should be able to tailor that to fit your organization. And open design proposals are just that. They can be scaled up, scaled down, made formal, made informal to match whatever's best for your organization. Critically, they're public and open for comment. Now, public should be, of course, scoped to what's appropriate for you. Maybe you're a private company, you don't want everybody to see your decision-making process in the public. But inside your company, where the stakeholders are all employed, they should all be able to see what's going on as you're making important decisions, because they're the ones who can tell you, oh, you've forgotten about, paragraph 4, subsection B of this export law that we are subject to, and you'd better think about that before you build some software. Typically, ODPs have standardized formats. This makes them easy to search, easy to archive, and easy to access after the fact, and that's really key. Coupled with that are that you keep archives, not just that they're archivable, but they are actually archived and searchable. And really, really importantly, deep in my heart, non-trivial review takes place. The people who make the design are writing it down, make it available for review, and they see the reviews, and they fold those reviews into what's ultimately produced. And we'll spend some time looking at some of the science behind reviews and why reviews are critically important and underappreciated in our profession. What do ODPs lead to? Well-documented, well-communicated, informed, high-quality decision-making. And these are probably things that you want, right? Nobody would say, well, we really don't want well-documented stuff. Of course you want well-documented stuff, especially something as important as a design decision that's going to affect a lot of developers. Of course you want it to be high quality. Of course you want it to be informed by all of the stakeholders in the system. So this is where ODPs, we think, can help a lot of organizations make decisions in a better way. I need to get some water here. This all might seem a bit abstract right now, and we'll get to very concrete examples of open design proposals, but I want to kind of preface things a bit so that you're not, your view of them isn't too colored by your own experience, because you will almost certainly recognize some of the examples that we talked about here in a bit. Now, I mentioned that open design proposals are based on what we call observational science. We are able to see things happening and in all these different successful projects and distill down. So it's critical that we understand that they're based on experience. We know that this approach works and has been fielded and used in many, many, many situations. I like this picture. So this is a picture of Texas, and these are the counties of Texas. It doesn't really matter what it's a map of. What's critical is, of course, that we're using 4 colors to color things in. Everybody sort of knows that you only need 4 colors to fill in a map and not have adjacent bits with the same color. Well, we've proven that. In 1976, we proved that. But prior to that, when this map was made, we just thought we knew it. It seemed right. We had never seen a map that needed more than 4 colors. So it was common knowledge, but not proven. And that's kind of where things like open design proposals are. I can't prove to you, I can't sit down mathematically and show you, if you do this, 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 and this, you'll get better software. But it seems clear. There seems to be a good trend. And this has the same kind of feel as that. They couldn't prove back then that the 4 colors were sufficient, but it really seemed to work all the time. And that's kind of how open design proposals are. They're very practical, very believable. They're not, they're very low ceremony, although they're high ceremony enough for your purposes, and that's really key. Coupled with that is that the self-evidence of ODPs is there. If you're an organization that could benefit from using open design proposals, you'll know it. You'll look at it and you'll go, oh, actually, that's a really simple, good idea. We could deploy that next week. This is a picture of double entry bookkeeping, right? You can do accounting without double entry bookkeeping. It's just really, really hard. And so if you're doing serious accounting, you're probably using double entry bookkeeping. In fact, by law, you are doing it in most countries in the world these days. But this was an invention. This was something that was invented by the Medicis or something 1,000 years ago or something along those lines. The point again, though, is that you will be able to tell quickly if open design proposals make sense for you. It's easy to get started with them. It's easy to modify them and tailor them to your environment, your particular needs, and it's easy to drop them. If you decide they're really not helping you, you just get rid of them. They're very lightweight, typically. So I spent some time telling you that I can't prove to you that ODPs work, but there is a lot of science behind certain elements of it, especially reviews. And we'll spend a fair amount of time looking at some of the details of why I say that, why I believe so fervently in that. And hopefully I can convince you, if of nothing else, that you should be doing more reviews than you're doing right now. Ultimately, this isn't rocket science. What I'm about to present to you is really kind of common sense, in retrospect. It's the kind of thing that once I explain it, you'd be like, yeah, that's actually practical and something very useful, but nobody does it, kind of like reviews. We all can be convinced that it's a good idea, but nobody does it. And this is, of course, a very funny picture. There's X. So I have a couple of public examples of open design proposals, and these are the things that you'll probably recognize. You've probably run into one or more of these in your careers, and hopefully this will convince you, now that I've kind of laid the groundwork and said why these things are so great, now you'll see, okay, they actually have produced some really excellent products, really excellent programs, and so forth. The archetype, the fundamental ODP is the RFC. Everybody, I'm sure, has run into an RFC. Anybody not know what an RFC is? A request for comment from the Internet Engineering Task Force. This is how we built the biggest thing ever, the Internet. These documents. They're all kept on some central directory somewhere on the Internet. You can download them all. If you want to understand the guts of HTTP or of UDP or TCP or any of the the Ps that run the Internet, this is where they are, including the hypertext copy pot control protocol. This is a real document. I don't think anybody implements it, though. It's kind of a joke, of course. 1st April, so it's yeah. Maybe somebody has, but I don't think it has any practical use. It's just funny. But let's see, what does the definition of RFC 2026 have to say about how to write RFCs and goal RFCs? Don't read the whole thing, but there's some bolded bits. Several iterations of review by the Internet community. So review and the community are involved in RFCs. They want a lot of eyes finding the problems in RFCs. Published. All the RFCs are available. You can go on the Internet, find them all, download them all, read them all, get really bored really quickly. High technical quality. This is the goal that they're aiming at. And they recognize that it's incredibly difficult and that the only way to get the high technical quality necessary to run the Internet is by having everybody who could possibly have input have access to the design process. And the importance of establishing widespread community consensus. This term consensus comes up over and over again in the various open design proposal definitions that are out there, the successful ones at least. So remember these keys, review, community, consensus, technical quality, published. These keywords show up in the other examples we're looking at. And of course, we know this works. I can download kitten pictures on my phone because of this. So we should all be really happy about that. You can download kitten pictures too. It's not just me. Joke. What are some of the details of RFCs? So what if you get down and you decide you want to write an RFC, what's involved in that? What do you have to think about and do? Well, you have to use their standardized ASCII format. You'll remember I mentioned that successful ODP implementations use some standard and typically very simple format, not Word documents. The drafts are published through a well-known shared directory. So somewhere on the Internet, it's probably copied 1,000 times, but there's one central place that has them all, probably at ietf.org or something along those lines. I should know that, I feel. Write it up there next time. The discussions happen in various venues. They happen at conferences like this. They happen on mailing lists. They happen probably over beers a lot at user group meetings. But the discussions that go into the decision making all have to be written down and archived. This is basically your rule. So you come to a conference, you have a big discussion with some people about, hey, we should implement this new protocol, here's how it should work. It can't stop there. It has to then get turned into something that's put into a document and published. Very straightforward, common sense kind of thing. They have a certain level of rigor, this notion of maturity levels. So a document first starts off as, infant stage and then child stage, and then eventually it becomes an accepted draft or not. Maybe it's rejected. But the archives of all RFCs, even those that are rejected, are maintained. And this goes back to this notion of domain wisdom. It's probably really important to know why an RFC was rejected, because somebody really smart said, no, if you do that, all the routers in the world are going to flip upside down or something like that. So it's good to know that. It's good to be able to go back and interrogate the past. So RFCs are not all that complicated in implementation, and this is a quality that you see over and over in ODPs. And this is why it's the kind of thing you can do as an organization very simply. All you need are, ASCII format documents in a shared directory that, are looked at by the people in your company. And then you can build the Internet yourself. Good. I'm a bit flip about this, but this is something that's so simple that I'm shocked that it's not done more often. Another example, and really the first one I have a lot of experience with, or had a lot of experience with, with is Python enhancement proposals. Does anybody here use Python? I love Python. It's my favorite language. Right, they have this thing called PEPs, Python enhancement proposals, which are just ODPs for the Python language. If you want to make a change to the Python language or the core standard libraries, you have to go through a process like this where you generate a document, something along these lines. Probably, if you squint your eyes and kind of fuzz your vision a bit, you can see this looks a lot like the RFC. It's probably, based on RFCs. The idea for this approach to design probably came from the Python community going, hey, the internet works, so we can make Python work the same way. This is, the first PEP. This is PEP 0. They start at 0, and it tells you how to write a PEP, so it's kind of a meta PEP. It's an interesting idea. But the very first PEP says how to write PEPs, and all the other PEPs follow that standard, so you've got your standardized documentation format for your design decisions. So here's another bunch of text. You don't have to read all of it again. I highlighted the important parts for you. That's Guido van Rossum, inventor of Python. PEPs are for collecting community input. So the community again, collecting the input. Documenting the design decisions. Documenting and design decisions. Consensus, building consensus within the community. Documenting dissenting opinions. He's really, well, the people who invented PEPs were really keen to make sure that they kept track of the people who disagreed with the way Python was going so that they could remember why they didn't make certain decisions. They want to remember the past because, of course, those who don't know history are doomed to repeat it. Edmund Burke, I think, said that. And this worked really well. This system, I can say from personal experience, was really successful in migrating Python from version 2 of the language to version 3, which is kind of now tailing off. Version 3 is pretty much the official version of Python these days, but there was a lot of uproar and a lot of churn in the language as they made the transition. And it was smoothed out because all the discussions happened in the open in a way that everybody could be involved with. And in the end, all the different factions, all the different communities that cared about Python were able to have their voices heard and coalesced into what is really a wonderful improvement to the language, in my point of view. What are some of the details of PEPs? Again, simple text files. There's a standard format with certain kinds of headers, and they all go into a Git repository somewhere on python.org. The format is partly specified. You have to have abstract and introduction, and then there's a bunch of freeform stuff at the end. So when I say a format, it doesn't have to be highly structured. It's not some XML document per se. It's whatever you need for your purposes. As you might imagine, for Python, the level of detail is often a lot less than what you get in an RFC, because the RFC affects so many more people. They're very different organizations with very different goals, Python and the internet. There's a big pre-PEP discussion on mailing lists, so often PEPs are shot down before they even become PEPs, much like RFCs. A lot of things don't ever become RFCs because somebody on the internet says that's a stupid idea and here's why. Rejected PEPs are retained, just like RFCs. PEPs are publicly accessible and discussed, python.org/PEPs, I think, and a reference implementation is often required. And this is an example here of Python taking the notion of ODPs and making it their own, saying, look, all this stuff is great, but we have to have this if it's going to work for Python. If we didn't require this, we'd get all sorts of stuff into the language that ultimately actually doesn't work. So they decided a long time ago that if you want to have a PEP into the language, you have to prove that it can work by proving that it works. So again, really simple, really straightforward, but extremely, extremely effective. And finally, do we have any Java programmers in the room? Java people. Wow, London has no Java programmers. We ran our workshop and there were no Java programmers. Well, there was one Java programmer in there. Everybody else was C#. So maybe you guys don't know about these, but Java has their own ODPs, Java specification requests. These are open design proposals for the Java language. If you go to the Java Community Process website, I've got a little clipping problem there, you'll see this picture. And this looks a lot more sort of formal and rigid than what you might have seen, what you'll see if you go look at PEPs and you look at RFCs. And that's because it is. It's much more rigid, much more structured, much more regimented, so to speak. You have to go through very specific phases. You have to get an expert group formed. You have to have early draft reviews, blah, 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 all this to get stuff into Java. But there's a reason for that. Java needs this because Java's stakeholder pool is much, much different from, for example, Python's stakeholder pool. For one, Java is owned by Oracle, and if anybody, I'm not making fun of Oracle too much, but they're a big, big company, and they're really concerned about making lots and lots of money. That's why they exist. Python doesn't really exist for that. They have different motivations. And so Python doesn't need to exclude people from the decision-making process or include some people more than others, but Java feels the need to do that. They have people who pay them a lot of money for that privilege. So to become, for instance, to become part of the JSR process, you have to join a club. You have to join the Java community or something along those lines, which is free for people like us, but for companies it costs money. There's no such thing for RFCs, as far as I know, and definitely no such thing for PEPs. And this is all because it makes sense for JSRs to be structured this way. So ODPs don't specify things down to the lowest level. They let you tailor the method to your specific case. So here's yet another, and I think this is the last big block of text, but again, I've highlighted things for you. High quality specifications. I think we saw that exact same phrase in the RFC description. Inclusive, consensus-based approach. Consensus has shown up in all three of the descriptions that we've shown. And this is just taken from their website. I'm not making this stuff up. I could never make up something called the Technology Compatibility Kit. And agreement on the form and content of the draft is then built using an iterative process. We saw that term before. That allows an ever-widening audience to review and comment on the document. Review and ever-widening audience. This notion of inclusivity, this notion of review shows up in all of these. And I think you could make a strong argument that this has worked really well for Java. Java has, it's Java 8 now, and it has all these fancy new features that everybody seems to love, lambdas and so forth. So this process, which is from 30,000 feet up, identical to what Python and the internet are doing to evolve themselves, has worked in all these cases, right? And it's recognizing that led 60 North to come up with this notion of ODPs, that we said, look, there's a pattern here. That's all an ODP is a pattern that has worked over and over for different groups. And we want to try to communicate that to you guys so that you can use it on your projects. And we've used it ourselves, and we know that it works. Some more details of JSRs. They're initiated by the community, but the initial draft is written by a committee. Again, this is much heavier, it's somewhat more heavyweight than what you see in PEPs or in RFCs. But that's by necessity. That's just because that's how Java and Oracle have to work. Membership is required, but it's free for us, so we can all go join, and if you feel like it, you can join today, because we have the internet. Now, those are all public examples. You could go out and read those documents and learn all about these things, just like we did. Some of you might say, well, I've been in companies that do kind of similar things, and I certainly have. I've worked in a couple of companies that have kind of similar approaches to design, and I have some anonymized examples of those that I hope will convince you that this can be done internally. You don't need thousands and thousands of users all over the world to make this work. You can have teams of 10, teams of 5, or teams of hundreds that can apply the same thing inside a company and help your architects make these really difficult design decisions, or just help development teams make right design decisions on a lower level. So one example is, well, I've anonymized it. I'm going to call it Initech, and they make red staplers. Space joke. In this company, proposals were developed by teams. So if I was team working on this part of the project and I wanted to make some new feature, I had to write a document in Word format. This was kind of a problem, actually, a functional problem in the company. And then make sure that all the other teams in the product, it was a fairly large piece of software, could see it and say, yes, this will work just fine, or no, you're stepping on our toes here and you're going to cause problems with this file save dialog or something along those lines. But all the documents were archived on a central file server. Everybody could access them in the entire company. There were mailing lists where big raging discussions would happen, and whole days were lost sometimes in these discussions. They were always very polite, but people felt they were right. And we would have discussion meetings. And in these discussion meetings, each team was mandated to have one person show up to kind of represent that team, but anybody who wanted to come was allowed to. So if I felt like I had some input, even though I wasn't officially the liaison for my team, I could go and say, okay, I think the font should be blue instead of red, or something along those lines. So again, you see, this is pretty simple stuff. Just a simple document in a standard format. It's archived, has discussions, and has review. The pattern we've seen over and over in the public examples. Another company, Burchicon, made laser sharks. This is where I have maybe the most experience with actually implementing an ODP style system. But the process developed, we actually developed this system to support a large architectural change, which is kind of why I motivate this talk by that topic. But we kind of sat down as a team and said, guys, we're going to be making all these big changes. We need to be able to keep track of why we're doing what we're doing. We need to keep track of all the influences, and we need to make sure that all the rest of the company can at least tell us if we're about to screw up, if not tell us, the right thing to do. And so we looked at things like PEPs and RFCs and designed our system around them. It was designed to promote accessibility and adoption, so we used very simple restructured text file formats and used our existing Git infrastructure to distribute documents, but we also published them to the web. This was key because nobody in management knows how to use Git. We've determined that 0% know how to use Git, and they're not about to learn it so they can read our design documents. But if we put it up on the web and ask them, hey, can you go look at this and tell me if this is going to impact you guys in any way? And then they can come back to you with a generally, I don't know. That's what they say. We use simple text files and discussions on mailing lists and in meetings and in review tools. Actually, we found that, so we were using Garrett for reviews. And the comments in the review tool were one of the most valuable sources of input into the design documents. And the fact that we had a review tool like that was great because we had a record, a perpetual record of all these discussions automatically. So if you're doing reviews without tools, you have to somehow keep track of the results of the review meetings. But if you have tools helping you, it's all kept for you. The technologies, just to give you a sense of how this is put together, will restructure text, which is just a kind of markdown kind of markup language. We used a mailman list server, so really simple 1970s technology in Garrett for our reviews. And these results were really good. Over about 2 years, we had 100 detailed review design documents, which is, by the way, 100 more than the company had before then. And this was a company making millions and millions and millions of dollars every year on important software, and they didn't have anything like this. And the software was really horrible, as you might imagine. We had a great archive of discussions and decisions, and this came in really handy because we could go back and look back 6 months and go, hey, we didn't do this because we didn't make the change you're advocating because we talked about it in the past and decided it was bad, and these are the reasons. And really, this was maybe the most important thing. There was broad understanding among the development team as to why and how the system was being changed and the direction it was moving in. Everybody was able to move in the same direction all the time without a lot of central control because they all knew where we were going. If any of you know James Copleen, a famous programmer guy, C++ guy, and he has this notion of, all together in the same direction at one time. This is how you write software the best way. And this gets teams aligned. This gets the magnetic field, in place to send us all in the same direction. It worked really, really well. I'm kind of glowing about it because it was one of the most successful sort of meta projects I've had. It produced some really great code, really great design, and it was really easy. And I think it paid for itself 10 times over. So how are we on time? Oh yeah, good. So I told you that review is one of the most critical elements of open design proposals. And really it's one of the big missing keys in a lot of software development, period. Whether or not you're doing big design changes, not doing review is probably hurting your team more than you know. And I want to try to convince you of that in the course of the next few slides. So there's a lot of research into code review and design review, and review actually at all levels. And it goes back to about 1976 when Michael Fagan at IBM was asked to study whether or not reviews are going to help IBM make better software. And IBM is interested in making better software because that means they make more money, because they spend less money on maintenance and so forth. It means they can deploy a mainframe and not have to touch that mainframe for 10 years, and it continues doing account balance calculations. He came up with a pretty sophisticated but very strict sort of cycle that you follow with roles and specific meetings and a very definite process and a big emphasis on data collection and metrics. And this was really, really influential work because he found effectively that you could reduce defect rates immensely and make your money back. I mean, IBM was convinced by this, and since IBM was convinced by this in the 70s, everybody was convinced by it because nobody gets fired for buying IBM. That was the saying. So this is really influential, and this is sort of the tip of the iceberg, the tip of the spear perhaps, for code reviews on the industrial scale. A lot of people ask questions about, well, do we need to have so much rigor? Is it really necessary to have this full Fagan kind of cycle to get all the benefits of review? Can we have a lighter weight process that gives us the same benefits or almost the same benefits for a fraction of the cost? And so this guy, Lawrence Vada, was one of the people who looked into this area and asked, really, are meetings necessary for design reviews? And his approach, part of his approach was to look at what are the reasons that managers cite for having meetings. They say synergy, education, people learn in the meeting, deadlines, force people, the meeting has a deadline so people are kind of motivated to get things done. There's competition because you're in the room and you want to find more bugs than Nancy and Phil on either side of you. Interestingly, a lot of managers said, well, we have to have meetings because the process says we have to have meetings. And this is, of course, brain dead when you say it out loud, but this is how some people think. So Vada basically debunked all of these and showed that you can actually get almost all the benefits of reviews without all of the big process that goes into Fagan reviews. And in fact, one of the numbers he came up with was that only about 4% of defects were actually found in meetings. The other 96% in his studies were found by people sitting at their desk reading the code. So essentially, the defects were found in the reading phase, not in the meeting phase. The meetings were good for, well, we'll get to that in a bit. Diane Kelly and Terry Shepard, they did some similar studies comparing groups versus individuals for code reviews. So again, comparing meetings versus reading at your desk. And they found that reading is effectively 50% more efficient at finding defects. So 1.7 defects per hour in their study just by individual reading versus 1.2 in meetings. Probably because meetings move slower, because there's the overhead of coordinating the people in the meeting. So this kind of confirms what Vada found, that really meetings may be detrimental in a lot of cases. Reidar Conradi from Norway, he wanted to study not code reviews, but UML inspections. And he found very, very similar numbers, that 75% of the time was spent in meetings, 25% reading, yet 80% of the defects in the designs were found while reading, 20% in meetings. So I'm not trying to convince you to do meetings or not, although I think that meetings, generally speaking, especially for lightweight design proposals, are typically unnecessary. They're important occasionally, but you don't want to make them a big part of your process, and hopefully these numbers can convince you of that. What meetings are good for are finding false positives. So if I come to a meeting and I say, I found these 4 defects, what do you think about those? And Bob down the table says, well, the first 2 of those are defects, this one is not a defect. That's the kind of thing. The detection of false positives is what these meetings are good for. A really interesting study by Frank Blakely wanted to compare testing versus reviews. A lot of people will say, well, if I've got a really good test suite in place, do I need reviews? Because the tests will catch all the problems that come into the system. The answer to that is no, that doesn't work, and we have a lot of evidence to support the belief, the statement that testing cannot replace reviews. So what he did was a really interesting study. This was with HP back in '91. They ran the development project, building a real product, and they did inspection the whole way, and they found 21 what they called major errors, things that would really have impacted the customers if they'd made it out. Then after the fact, they analyzed their test suite, said, okay, we know we found these 21 errors. How many of those would the test suite have found? And the answer is 4. That's kind of pathetic. I mean, that's 20%. So 17 critical errors would have gone through out to deployment, potentially, if they had relied on testing. And HP is, they're not a bunch of slackers. They're really smart people with probably a really good test suite. But it pales in comparison to the power of reviews and inspections, and this is what I want to drive home to you so much. Okay, people say, okay, inspections, okay, yeah, they sound great, they're going to improve our quality, but they're going to cost a lot of time, right? This is a new thing we have to do, and it's going to slow our process down, and we're going to, be late to market. And that is also pretty much a lie. If you look at study after study, what they show is the time spent in setting up a review regime and following it saves money every time. You get this HP, a 10-to-1 return on investment for reviews, $21 million in a year. AT&T Bell Labs, 10-fold quality improvement, and you can read all these, get the slides, and hopefully these are the kinds of numbers you can use to convince your manager. Your manager says, you guys are going to be spending a lot of time in doing reviews. Is this going to pay for itself? The answer is yes. Time and time again, these things pay for themselves. And I'll give you references also to where this data comes from. This all in books and research articles and so forth. Now, when we think about reviews, especially in the software context, we tend to think a lot about code reviews. We think that somebody's written some functions, and I'm going to go look at those functions and find all the bugs. The reality is you should probably be spending more of your time, in fact, you should almost certainly be spending more of your time reviewing design documents, things like open design proposals. So this is from Tom Guild, who's a big name in the kind of inspection regime. He was a colleague of Fagan's and followed along with more research along those same veins. And he said that in a big Belcourt study he was involved with, 44% of all bugs were due to defects in requirements in design. So basically, programmers were given something to do that was incorrect, and they wasted a lot of time implementing something that they should never have implemented in the first place. And this happens because programmers can do whatever you ask them to do, right? If you tell them that all the text on a page needs to be upside down, probably make that happen, but it's almost certainly wrong, right? So you want to make sure that you're spending your time with reviews in the most efficacious place, and that is almost always early in the process, if that's an option for you. Review your contracts, review your design documents, review your UML diagrams if you have that kind of stuff. Everything up to the code, and in fact, don't review the code if you can review this other stuff and you feel like you don't have enough time to review code. Reviewing code is typically one of the least effective ways to do reviews. But I don't want you to not do it. I still want you to review your code, but just bear in mind that there are orders of magnitude difference in the effect on quality. With that said, one of the reasons that we want to do reviews, one of the most powerful reasons is feedback. We educate the people involved in the process. So if I create some artifact, a design, or a piece of code, or whatever, it goes through review, and people find defects, and I see that list of defects, and I learn not to do that again. It's by eliminating defect injection, reducing defect injection rates is the sort of term of art. That's how I get a lot of benefit out of even things like code review that may not have an immediate impact on the quality of the code that's being reviewed. The benefit comes from educating the person involved in the process to not make the mistakes they've made already. So yeah, keep that in mind. I want to put up some quotes from Robert Glass, who is a great writer on these kinds of topics. Research study after research study has shown that inspections can detect up to 90% of the errors in a software product before any test cases have been run. That signifies an extremely effective process. Yes, it's an extremely effective process. So it's kind of shocking that we don't do more of it as an industry. The same study showed that the cost of inspection is less than the cost of testing. It would be necessary to find the same errors. What we have here is an effective process that is also cost-effective, and that's a pretty nice combination, okay? Two kind of understated statements saying if you're not doing review, you're throwing money out the window. That's going to sum up what Robert Glass is telling us here. You can read all about this stuff yourself. Convince yourself. Don't just take my word for it, but get some of these books. If you're really interested in reviews, this is maybe the place to start. This is by people at CodeBear, which they make software review tools, so they kind of have a finger in the money pie here, but it's a very good book that points to a lot of good research. This is just a fun book overall. This is not just about reviews. It's about all sorts of silly things that we believe in software development but probably aren't true, or at least don't have an actual basis in fact. Things like cones of uncertainty and the cost after deployment curve of fixing defects and stuff. Those might be true, but we really don't have any proof for it. But we all believe it. It sounds true. Because these things sound true, you should also read this book, The Leprechauns of Software Engineering. This is a wonderful book that will make you a skeptical reader, will help you sharpen your brain to understand all these other things that I'm suggesting you read. What should be on this list also is Capers-Jones, The Economics of Software Quality, an excellent book filled with data that will educate you, well, in huge ways. It will also bore you. It's a very dull book, but full of really good information. So that's review. I hope that if nothing else, you leave this room believing that you should be doing more review, and definitely review of your designs. Definitely review of your high-level goals and your visions so that you align everybody and you avoid the miswork that Tom Guild talked about earlier. So what are the benefits then of open design proposals? If you implement these, what are you going to see? What should you see? What have we seen happen over and over again? In a nutshell, you're going to improve your quality through communication. That's what it amounts to. You have everybody reading the same things, commenting on the same things, writing the same things. Everybody agrees, and everybody has a voice in the in what gets done. And this has all sorts of benefits, not just code quality, but team morale can go up, and everybody feels enfranchised. Right, this is really important. You'll be harnessing the power of review, so you'll get the right input at the right time. You want to make sure that as you're doing open design proposals, you let people make comments as early as possible. As soon as you've made a draft, say, okay, here it is, folks, start commenting, and go to town on it. This way you can get really quick coalescing of thoughts and coalescing of ideas. And really get maximum power from review. There's a lot of reasons to believe psychologically that having reviews come quickly after doing the work are much more effective because everything's kind of still in your brain. If I write a bit of code and you review it 20 minutes later, I still remember what that code is all about. If you review it 6 weeks later, I have to go remember what that code is all about. And it's just a harder thing to do. And I might not be as concerned about implementing all the fixes you suggest. ODPs they leverage the straw man effect, which you might not believe. I mean, you might not believe in the straw man effect, but I like llamas, so I just put a picture of a llama up here. I couldn't find a straw man. The idea is that by getting something concrete in front of you, a document that you can read, your brain is better able to pick it apart. Your brain is better able to be critical and effectively apply its thinking skills, which is what brains do, to the design proposal. If I come to you and kind of wave my hands and say, hey man, I want to write this new subsystem that does such and such, and it's going to talk to this thing over here, and it's going to write in this file format, you can kind of agree with me, but you don't have anything really concrete to knock down. You want a straw man that you can knock down, because it just sharpens our minds. So if I come to you and I just talk about llamas, we can kind of agree that llamas are kind of okay in some ways and maybe not others. But if I come to you with a list and talk about the benefits of llamas, you can immediately say, no, they're not good at algebra. They're terrible at algebra. We should cross it off the list. You have something very concrete to nail. There's a great speaker, a Perl guy named Damian Conway. Has anybody ever seen him speak? I suggest you do. He wrote a language in Latin that translates into Perl, and it's just fascinating. He's a really, really great speaker. But he gives some really great writing advice, maybe the best writing advice I've ever received, which is somebody asks you to give a talk, something like this. And a lot of people who maybe haven't given a lot of talks will sit down and scratch their heads and think really hard about what are like the 5 most important things I can tell you about Docker or whatever it is you're supposed to talk about. And you'll struggle and struggle, and eventually you make a list of 5 things and you give your talk. How do you really know those are the best, most important 5 things to talk about? It's really hard to say. His advice is sit down with a blank sheet of paper and a pencil and write down everything, every topic you can think of in Docker. Write them all down. Then stare at that and pick the top 5. And that's a much more effective way to find the best things to talk about. And this is the same effect. Like putting everything down and putting it in front of you, you get a concrete thing to, well, not a concrete thing, a straw thing to stare at and to catalyze your mind. It's the same effect. Writing things down is really important. And that's really the next slide. Writing aids in thinking. I cannot stress this enough. If you're not writing a lot about what you're doing, you're missing a whole half of your brain is just not being engaged in your design processes. Does everybody know why there's a rubber duck up here? Yeah, so there's this notion, okay, you've probably all been in this situation. Is everybody a programmer? Right, okay, yeah. So you spend all day trying to fix some bug, and it's just like, you just can't figure it out, and there's race conditions somewhere, and sometimes the font's all messed up, and you just can't figure it out, and you're trying everything. You've tried 6 different debuggers and whatever. So you say, fine, okay, I have to go talk to somebody. So you go down the hall and you go to Alice and go, Alice, I've been trying to fix this problem all day long, and I made this change and it does this, and then this subsystem over here just started freaking out, and all of a sudden you stop and you look up and go, I figured it out. Thanks, Alice, and you walk away. She didn't say anything. She probably didn't even stop typing because this happens all the time. Because by stopping the typing and stopping the cogitation and talking, changing the modality of your thought, you figure it out because your brain becomes more powerful. And there's plenty of studies in neuropsychology or neuroscience that talk about the different modalities of thought and how we just become smarter if we do things like talk about things or write them down. So I can't stress enough the power of talking and of writing things down. The rubber duck is Alice. So what you're supposed to do, the reason he's up here is because you have a really tough problem. You can't solve it. Rather than going down and bugging Alice for the 10th time, you pick up your rubber duck and you explain the problem to the duck. And the duck will help you. The duck is magical. The duck gives you superpowers. It doesn't have to be a duck. I mentioned I like llamas. I have a llama on my desk that I talk to, not a rubber duck, although I do have a rubber duck as well. So get one. Get a rubber duck. Get something you can talk to and explain your problems. It's kind of your psychotherapist for software development. Another big benefit of open design proposals is it gets everybody involved, and that enfranchises your development team. They don't feel like ivory tower architects are throwing designs at them and telling them to make it work and then going on vacation, which does happen. So getting everybody involved and allowing them to make their input known and to have their input processed and be visible in the design is really important. Even if they don't actually change the way a feature is going to be implemented. They at least feel like they had a voice, they had a chance to find problems. And they suddenly, not only do they feel enfranchised, they also feel responsible for the design because they didn't see the problems that might be in there, but they had plenty of chances to do it. So this is really important. And it really gets people thinking in different ways. You have a lot of people, especially at big companies that I've seen, who they can sit in a corner and they can code on their own little thing all day long. And they never really progress beyond being that coder who sits in the corner and programs all day long. But when you get people involved in bigger designs, you get them involved in architectural evolution discussions, they become not just better programmers, they become more valuable employees, more valuable members of the team, because they start to see how to think in broader scope. This is great for junior developers who've only just come out of college and have only ever worked on small projects. Get them to see how things work, in the large, so to speak. Finally, you get an archive of your designs. I picked this picture because it's a great picture of a warehouse, but then I realized it's an awful picture because who knows where this is from. This is the end of Indiana Jones when they put the Ark the Ark of the Covenant in a box and put it away, never to be seen again. That's not what I want you to do. I want you to see your things later, but archive them somewhere and then label them so you can find them. Now, typically this means put your design documents in a Git repository that has an index perhaps that you generate somehow. This is really easy stuff to do. Or use restructured text and Sphinx like I did at one of my old companies. It just makes it really easy to go back and peruse the decisions you've made and kind of get a sense of the history of a project or the history of a large design change. And it gives you something tangible, something visceral that you can look at and say, this is another thing we've done. We don't just have software, we have history. We have, it's got a kind of gravitas to it now because you've built something that's really useful and has a lot of very valuable information that often is just thrown away. So how do you get started? We are going to end quite a bit early, it looks like here, and I apologize for that. I talk fast, I know. But how do you get started? It's very, very easy. You need a spacebar that works. Yeah, you need a mailing list and a web server. That's pretty much it. You need a place to put documents that people can read, and you need a way to talk about those documents. You probably have those things already. If you just want to try an approach like this, it can be really lo-fi. And it doesn't have to grow much beyond this. I've seen a system like this work for teams of 30-ish developers. No problem. That's really all you need. If you want to get more sophisticated, you can really organically grow this, and you can add in things like review tools like Garrett or Code Collaborator and so forth. Revision control, which I do suggest. Everybody's got a Git repository these days, so just drop your documents in there. Maybe you decide that you need to have meetings. Maybe you make pacemakers or something like that, and you really need to have that extra 4% of safety. But if all you're doing is, what's the joke project these days, fashion aggregation or something like that, you probably don't need to have meetings all the time to find all the bugs in your system. You can have more structured document formats. Maybe you have something that's more searchable, simpler than just, or more searchable, but more complex, something with metadata beyond just a text document. And you can have whatever sophisticated processes you need. Maybe you are like Java and you need to have a more heavyweight process that involves people in sort of these concentric waves. Probably not, but maybe you do. So tailor the methods to your organization. There's only 2 slides in this section because really it's very, very easy. Sit down with your team and say, hey guys, how can we document our design decisions better? We have a few guidelines that this guy in London said we should look at, and maybe they make sense for us, maybe they don't. But at least think about it. That's all I've really got to say. So we're about a half hour early, which at the end of the day, maybe it's not such a bad thing. So I'm happy to take questions or talk about this stuff. So yeah.
Can I have one question?
Mm-hmm.
Sounds very nice, but I want to just give you details of what we do and get some advice. That's not a problem. Just a few minutes because we try to build up. We have a wiki page where we try almost everyone from the team. So anyone can go there and put a page, put some description, if what he's changing or what he's doing.
Yeah.
But that's kind of not working because it is out of date very fast.
Yes.
So after 6 months, you don't need to go there because it's old. Nobody is updating what he changed.
I can give you some advice on that front because we had the same experience at the last real company I worked at. They had a wiki for years and years and years, and everybody knew the wiki was the place where text goes to die and never be seen again. Right? It's this hole that you throw stuff in, and it's like SharePoint, kind of the same way. You put stuff in there, and you never go back. And the reason we think that happens is because everybody owns the wiki, so nobody owns the wiki. The successful implementations of ODPs that I've seen, there's somebody's name at the top of the document that says the author is Austin. And Austin is responsible for the quality of this document and making sure that it reflects reality. So go talk to him, and it's his responsibility to keep it up to date.
So that's my question. You're saying that open design proposal, every open design proposal should have an owner?
I think so. I can't say I've seen one that doesn't have the notion of ownership of documents, but my sense is that by having ownership built into the process, you force people to pay more attention, to be more, just be more active in maintaining the quality of the documentation. I've definitely seen that work.
Okay, so my next question is, now we're starting to use PowerPoint as a file format, because we have a lot of research way of drawing things easily.
Right.
You know, with this you can do a lot of funny stuff like animations, or for example, we have a queue and we want to show how there are messages coming into the queue and so on.
Yeah.
So do you think this is a good format, or can be used for open design proposal?
I think it's fine. I think okay, I wouldn't want to use PowerPoint as my primary top-level format. I would still want a text document or something more searchable than a PowerPoint presentation, so that I can quickly scan and see what documents I have. But I've seen plenty of design proposals that have a kind of text document that lays out most of what's going on and that refers to drawings done in OmniGraph.
Drawings outside of the text document, and then you still have the text document.
Right, and if you use something like Markdown or Sphinx or restructured text, they often have great facilities for having links to external documents, and sometimes those can even be embedded. A lot of the diagramming we did, my last company, was done with SVGs, scalable vector graphics. And we just embed those directly in the web page that was generated by Sphinx. So it worked out really well. You had sort of the best of both worlds. But I'm not going to say don't use PowerPoint as your primary documentation format, but I would shy away from it. But it depends on your organization. Again, I mean, if that's what everybody's happy with, that's perfectly fine. And maybe SharePoint has a way to index PowerPoint documents that will work for you guys. I don't know.
Something we have trouble with is fitting this kind of process into an agile iteration. So you don't want to do this thing too early, because you might never do that piece of work. Right? You might never get to your iteration. You might get thrown away before you get that far. And you don't want to do it too late, because then it affects the predictability of how you deliver that iteration. So any ideas about how you fit in the timing of that?
Yeah, we were using Scrum when I put Scrum in quotes, because we was kind of going through the motions, but we had sprints and things like that. And typically the way things would go was we would have discussions before writing any documentation, before writing the design. We'd have just not even meetings, sitting over lunches and discussing things. We would know pretty much that we were going to go in a certain direction by the time we started writing a document. The document served as a way to get the ideas into the public, into public view, and then to align everybody who might be working on it. So I definitely agree. You don't want to use this as the starting point for a discussion. You want to use it once you've more or less agreed that this is the direction you're going in, or that you need to make things more official, that you need better documentation in place to make the decision that you have to make. And so if you look at like how the RFCs work and how PEPs work and all that kind of stuff, they all go through a phase where they're not really RFCs or PEPs yet. They're just a discussion on the mailing list. And it's only after things reach a certain threshold of reasonableness that they become more official documentation. Yeah.
Touching back on the first question, so how do you motivate people to want to do it? So ownership is what we strikes to a particular personal motivation and recognition, fundamentally. Now, sometimes within teams with the junior developers, that's not their motivation. Yes, you need them. They are a very valuable part of the community. Yeah. So how do you motivate?
This is a social problem, right? This is that's what Peopleware says. There's no technical problems. It's all social problems. This is technical leadership, and this is the application of senior members showing how it's done, being the example, and then trying to. It's typically going to come down to the senior people doing these kinds of things, at least initially, because they're the ones in a position to make a big decision, right? But when the junior members see that this is how decisions are made, and if they want their decisions to be heard, they're going to have to get on the same boat and kind of write these documents. So they'll be socially motivated to write these because they want influence. But they'll also hopefully see the efficaciousness of these approaches. They'll say, look, this really does work. We have really great designs and we know how we got there. Hopefully they can be convinced by that. There's always going to be people who just want to code, right? I mean, that's what you get a lot of in programming. I don't know if there's any solution to that except to don't let that block the rest of your team, you know. But I really think it's really a technical leadership kind of thing. It's what Jerry Weinberg talks about, you know, how to be a technical leader is lead by example and just do things right, and everyone else will see. It's kind of a consulting answer, I know. Yeah.
Picking up on that point, what I've encountered is a lot of apathy. You'll send a document out, you'll ask for feedback, nobody bothers, and in the end you call a meeting, get them all together, because
Okay.
it's the only way they'll actually go through it.
Yeah. Maybe that's what you need to do then. I mean, maybe you can't have such a lightweight process that people can ignore it at first. And it's not a silver bullet. I mean, if your design team just doesn't, if your developers just don't want to be involved in anything but coding, then maybe you're kind of hosed. But in my experience, though, at the companies I've worked with and the places I've consulted, people aren't that apathetic all the time. The majority of developers really are interested in things like quality and shipping good software and understanding why their software works. And so maybe you have to take baby steps to get to the point where the team is all moving in the right direction. But in my experience, when you institute reviews, and I talked about this in our code review workshop earlier, you typically start small, doing code reviews in just a small team. You get the tooling in place, and you kind of get a process that works for that team, and then it grows. And it grows organically, and it happens almost magically, because once people see how well it works for this bit of code, they say, well, this project, we want to use it too, because that's really great. And then all of a sudden you say, well, we also want to apply it to design documents. And you start reviewing everything, which I think is perfectly wonderful. So start small and let it take root. But you're going to have to be very diligent too. I mean, if you're the one who brings in the concept of reviews, you have to push it and make it work in your organization, whatever that means.
On that point, so you typically have, say, a list of everybody in the team, and they would need to tick a box in the review tool, so you've at least given it some thought.
Yeah, yes. I mean, my preferred approach is you use something like Garrett. I think it's a great tool, and you can pick a person that you think is a proper peer who can actually do the technical review, but then you can also say, I think that newbie 1 and newbie 2 ought to look at this as well, so they can see how things are done. Reviews are a great learning tool. So yeah, you should be able to select who has to do the reviews, and if a manager has to make that decision, at first at least, maybe that's a reasonable thing to do, but typically developers know who the right people are to do a review. Yeah, go ahead. No, go ahead.
Regarding when you talk about the reviews must be open to public, or you have to set a scope. What if we have too many managers?
I can't solve that problem. I'm sorry.
I mean, we have to set some boundaries somehow. Is there any kind of polite way to tell them that they should be joining us or something like that, or is it good if they just take part of the whole thing, but their contribution is just
What are the stakeholders?
But if I understand the question, you've got a bunch of managers that don't want to be involved.
no, yeah. Sometimes they want to be involved. The problem is that their contribution is not exactly the right thing.
Oh, okay, they're pushing in the wrong direction.
Yeah.
You've got 24 spelling mistakes. The fact that you've got a deadlock issue,
Yeah, spelling mistakes are a problem. I don't know. This probably depends a lot on the specifics of the organization, but count your blessings if they want to be involved at all. A lot of people don't. And I don't know. I mean, misspellings are a problem too. You want to write those down, so it's good to keep track of those. But, yeah, I don't know. 'Cause I've never really encountered that problem where there's like sort of too much noise in the system. Typically, the problem is there's not enough involvement in people are having to, champion and promote the concept of review until it sprouts. Yeah.
I have one more. About the code reviews, you mentioned I have always one teaching point of view that we're doing code reviews, but we're talking about always should we allow the code to go in the source control repository before the review?
Yeah.
We can
advice is don't put code don't put it onto your trunk until it's been reviewed.
Yeah.
Because what happens then is, of course, everybody clones your trunk and you just foobarred everybody's systems for a day. So you've multiplied your problems across the team. Most modern review tools, like Garrett, which again I love, lets you submit to the Git repository on like kind of a magic branch that people then go and review, and then once the review process is done, you get merged in. But you don't want to poison everybody else's development environments with your changes.
Are you doing only code, you're looking at the code, or you need to deploy that change to the system and test that change that is functional?
Yeah, you can set up.
Also functional reviewing. If I change something, the guy who is doing the review needs to deploy that.
Yeah.
If you do that in a separate branch, it's an option. Always people complain, say, okay, that's too complicated. Download a different branch, then execute all steps to deploy that initial system and test that. So they say, okay, I prefer to be in turn so I can get less and automatically get that change.
Right. I think you have to tell them that.
That's not
have their boss tell them how to do their job, and it's unprofessional to not want to use the best tools that they have at their disposal. Ultimately, it's not that complex. I mean, once you go through the workflow a few times of fetching somebody's commit and deploying it on your system, especially if you have something like Jenkins helping you. I mean, you can make these things really smooth.
No, problem is that we do Scrum and we normally do the reviews to be the really important thing. So if I finish that, we want to do the review immediately, so the testers can catch that faster.
Right.
We don't wait. But some developers, they're in the middle of a big task and they're in the turn with a lot of local changes. So they're just ahead in front of the computer down and then just tapping off 5 days, and they don't want to get another branch and then change the context, deploy another system, lose, let's say, 2 hours to do that.
Yeah.
So they always say, okay, when I finish that, then I'll do it. So it's kind of just a, question if you have.
I mean, I think this is
I
think it's just a technical problem because certainly with things like Barrett, I know I keep hitting there because it's the tool I know best, but if I've got 5 days worth of code on my desktop, it's easy for me to basically stick that off to the side, hit change down, just using standard Git tooling, and test it out, and then say, okay, everything's fine, and shift back to my working branches. It's really trivial, exactly what these tools are designed for. But if you've got older tooling, if you go back 10 years, against the tools that were available back then, yeah, maybe these guys have been burned by their older experiences.
Yeah.
They just don't want to get burned again. I don't blame that. It's awful. Okay. Well, thanks. And yeah, I'm happy to So my name is Austin Bingham. I work for and part own a small company in software consulting and development company up in Norway called 60 North. And as you can see, I'll be talking about high quality decision making using something we call open design proposals. These are nothing revolutionary. You've probably seen things like them before. We just kind of put a name on it and tried to classify what we mean, what are the good things about these different design approaches we've seen used in open source and closed source projects, and turn them into something actionable for teams that are doing design, doing architectural evolution, or something along those lines. Right, so let's just dig in. So, as you can probably tell from my accent, I'm not from here, and I'm also not from Norway. I'm originally from Austin, Texas. This little orange dot over here, that's the home of the University of Texas, Hook'em Horns. And it's a great city. If you've never been, you should definitely visit. It's great food if you like kind of spicy food. They're big in Tex-Mex there. I like this picture because it shows the city in the background. It's a beautiful city, not a big city, but it's nice. And it's a statue here of a guy named Stevie Ray Vaughan, who's a local music hero, great guitar player. And Austin's really big on its music scene. And I like the fact that we have a statue of him in the town. About 6 years ago, I moved to Stavanger, Norway, here on the west coast of Norway. It looks like rollers, and when the wind blows and the building starts to go this way, the block comes over this way, and the building's center of gravity stays more or less the same, so the building doesn't fall over. So this block is important for the building's stability, so it doesn't crash down into Manhattan. So they build this building, right, this building is up, people are working in it, it's in the middle of one of the most crowded cities in the world. And this graduate student in Canada, architectural graduate student, gets an assignment to analyze this building. And she does some calculations and kind of scratches her head and does some more calculations and eventually concludes that if a strong enough wind hits this building on the corner, it will fall over, right? Now these are called quartering winds, I believe they're called. And they're typically not calculated for buildings, or they're not followed up very closely because they are almost never relevant to typical skyscrapers. A skyscraper with its corners, with corner supports, isn't affected that much by quartering winds, and so they didn't pay much attention when they built this building. But it turned out that, in fact, this building was very susceptible to quartering winds. And she figured this out and, you know, sent him, not an email, because this was back in the 70s, but some kind of letter to Mercier and said, hey, you know, I think your building might fall down. And he said, well, he kind of looked at it and did some numbers, and he concluded, in fact, it would. It was very susceptible to these high winds. Now, these weren't typical winds. These would be winds that would come in something like a hurricane. So he did some calculations and said, okay, if a hurricane comes along, it's going to have a certain, you know, velocity of wind, knock the building over. What's the likelihood that it's a lot different? This is a fjord here, the most beautiful fjord in the country and probably the world, and nobody can argue against that. This is right in my backyard, literally about 20, 30 minutes away. Really, that's what the whole country looks like. But the statues in Norway are a bit different. This is down really close to my house, actually. The three swords, they call it. These 20, 30 meter high swords jammed into the earth, representing the unification of the kingdoms of Norway back in, 1300 or something along those lines. So both great places, both beautiful places to visit. Don't come in the winter. Maybe come in the summer if you're coming to Norway. Otherwise, it's just kind of cold and dark. Unless you like that kind of thing, you can go skiing. But enough about me. Oh, yeah, and 60 North, it was founded up in Norway about 2 years ago. So we're talking about open design proposals, and we'll get to what that is, but I want to kind of motivate the discussion a little bit with a discussion of architectural evolution, which is where I sort of have applied these techniques the most and sort of the most rigorously. So what is architectural evolution? So we can start with a little story. This is the Citicorp Tower in Manhattan. So it's not really the Citicorp Tower. This is a Lego representation of the Citicorp Tower, but it's the best picture I could find of the building, so I chose that. But architectural evolution are changes to architecturally relevant aspects of a system you can read, and particularly to the form, the shape of the architecture, not the technology so much. And this building is really interesting from an architectural point of view, an architectural evolution point of view. If you look down at the bottom, I think most of you can see it, there's this little gray building here, and that's a Lutheran church that's been in Manhattan for 100, 200 years, a long time, long before this building was conceived of. And it's in the middle of, some of the most expensive land in the world. So Citicorp decides they want to build this building, and the church says, well, you can build your building on this block, but you have to build over us. You have to somehow build your tower to sit on top of us, and we're not moving, we're going to stay here. And Citicorp said, well, okay, we can probably sort this out. And they hired an architect named Le Mercier. I'm sure I'm slaughtering the name, but a French architect, and probably the most famous architect of his time. Certainly very influential and smart guy. And he scratched his head and thought about it and said, okay, yeah, here's what we can do. What we can do is put supports for the building here, not at the corners where you would typically put the supports for a skyscraper, but put them on the faces. And because of that, inside this building, there are these chevron bracing structures that kind of focus the weight onto these. I'm focusing the weight. I'm not a civil engineer. I don't know if that's a thing or not, but that's how they made the weight of the building sit upon these pillars. This new sort of revolutionary design. And this design is great. They did all the math. And they said, yeah, the building is going to be just fine if we built it this way. It turned out that this design made the building exceptionally light, so it would move a lot in the wind. And they calculated all this ahead of time. They knew how to do this. So at the top of the building, there's this 55-ton concrete block. It's controlled by a computer that a hurricane of that strength is going to come along sometime soon. And once every 55 years, roughly, is how often you would see a hurricane of that strength, which do show up in New York. So he kind of wiped his brow and said, good, we've got time to fix the building. We've probably got 20 some odd years to fix it statistically. But then it occurred to him, wait a second, what else happens when hurricanes come? Hurricanes show up and they knock the power out. And when the power goes out, concrete block at the top of the building stops moving. And then he said, well, this is really bad because now hurricanes that can knock this building over come once every 16 years. And then he looked at the weather and said, and there's a hurricane out in the ocean right now coming our way. So he's freaking out. They've got this building, people are in it, and it's going to get knocked over by a strong enough wind that shows up. And they calculate the way to fix it is to go in and to put in some special rivets all throughout the building. And they did this in complete secrecy. Like the people are like, doing whatever it is they do at the Citicorp Tower. And there's teams inside the wall putting in rivets, and nobody's telling anybody. I think the emergency teams knew that this building might fall over, but that's about it. In the end, the day was saved. Right? The building still stands today, and it's still sitting on top of a church in the middle of Manhattan. The reason I like to tell this story is because this building represents an evolution in the architecture of skyscrapers. Skyscrapers, at this point, we knew how to build them. We've been building them all over the world, and they stood up. We understood. You put the weight on the corners, and they stand up, and hurricanes can't knock them over. Not a problem. But because of this new factor that nobody ever had to deal with before, it forced a change in the architecture of the building. And even something that we've been doing for thousands of years, building buildings, we screwed it up in this